Okay, so YouTube recommended me to watch this video today, and I was kind of shocked to find out that it's already 7 years old because I do remember watching it and it feels like yesterday. So let's travel back in time to the place where Hoonigan wasn't bankrupt yet and Ken Block was still driving, and let's recreate, let me find it, this gear indicator from the Hoonicorn Mustang. And let me show it to you again, this gear indicator, because it's really visible only for a fraction of a second. And this is how the finished project looks like. It's using the Arduino connected to the OBD2 port of the car, the onboard diagnostic port, getting the data from this port and showing the gear on the DWIN display. And so today I will show you how to do exactly that from start to finish. Now this is not my first video about the custom gear indicator. I have a complete playlist of I believe 8 videos with a lot of details, different displays, all dedicated to a custom gear indicator. And you should definitely watch them if you haven't seen those videos already. The second thing I want to talk about is the sponsor of today's video, which is PCBWay. And that's because if you are making projects like this, sooner or later you might need custom PCB or maybe SMD stencils or maybe services like CNC machining or 3D printing. And in all those cases, PCBWay has you covered. They offer all those services for a reasonable price. By the way, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our project. Now there are many different ways how to get the current gear from your car. In one of my older videos, I was getting the gear based on the shifter lever position using Hall sensors, that's this video. But today I want to try something different, and that is to get the gear value from the OBD2 port. The OBD2 stands for the onboard diagnostic port. It looks like this. I have this OBD2 simulator, so I don't have to sit inside the car when I'm recording this video. But the same port should be in your car, usually located below the steering wheel. And I also have this video, quite a recent one, where I was getting the speed and RPM values from the OBD2 port and showing those values on the Nextion display. And I will take this project as a starting point and build on top of that. Again, in here I'm getting the speed and RPM values by sending what's called the PIDs, the parameter IDs, and receiving some response. And there is a Wikipedia page which lists many OBD2 PIDs, so let me search for RPM. And to get the RPM, I'm sending the PID 0C in the hex code, and then to get the vehicle speed, I'm sending the PID 0D in the hex code. If I search for the gear, there is the PID being A4 for the transmission actual gear. The problem is that this PID is quite recent, and all my cars are quite old and do not report this PID. So instead of getting the gear directly from the OBD2 port, we will calculate it based on the RPM value and the speed value. Because if you think about it, the car has the engine which is turning at some speed, and we know that speed is the RPM, the revolutions per minute. And then the car itself is moving at some speed, and we also know that speed, that's the kilometers per hour or the miles per hour. And so there is a connection, there is the equation between the RPM value and the speed value, and it's being determined by everything in between. That includes the gearbox, so the current gear, that has some gear ratio. There is also most likely some gear ratio inside the differential, and finally is being affected by the tire size. So if you multiply the current RPM value with the gear ratio inside the gearbox, inside the transmission, then multiplied with the gear ratio inside the differential, and then multiplied by the tire size, you should get the current speed. However, we already know the speed, but we don't know the current gear. And you can find gear ratios for different transmissions, but you have to know which transmission you have inside your car. And you still have to know the gear ratio inside the differential and the tire size. So what if we simplify this equation and say that the final speed equals the RPM multiplied by some multiplier, and the multiplier will include everything in between, meaning the gear ratio inside the gearbox, inside the transmission, the gear ratio inside the differential, and the tire size. So the RPM multiplied by this number equals the final speed. And let me actually show you this graph from some random website, and that will hopefully make it easier to understand. So this graph shows the connection between the speed, between the miles per hour on the x-axis and the RPM on the y-axis. And we can say that with this particular car, if we are driving at 50 miles per hour and we are revving at 4000 RPM, we know based on this blue color that we are in the third gear. And we can get our multiplier simply by dividing the RPM by the speed, so 4000 RPM divided by 50 miles per hour gives us the number 80. So in the very similar way, we can say that if we are driving at 65 miles per hour and we are doing about 5200 RPM, so again 5200 RPM divided by 65, that will give us the same number being the 80, and we know that the 80 for this particular car means the third gear. So the only question is, how do we get this graph and those multipliers for those individual gears? Well, again, I think that we can use this project. And that's because we also show the RPM and speed values, but we are showing those as two independent values in the form of two gauges. So we need to adjust this project to show those two values inside the graph, where again the x value will be the speed and the y value will be the RPM value. So let's actually do that. Same as the last time, I'm still using the Nextion intelligent display in the size of 5 inches with the resolution of 800 by 480 pixels. And also same as the last time, you can use the 7-inch version as well because it has the very same resolution. I've used that one for the Digifizz dashboard recreation. So let's open the Nextion project from the last time in the tool called the Nextion editor, and it looks like this. And if I run the simulation, we have two invisible sliders for testing those gauges, but of course in the end we are sending values from the Arduino. And I don't think that we need any of that, so I'll just select everything and delete it. I will also delete all the images by clicking this trash bin icon, so delete all the images. And pretty much the only thing that I want to keep are those fans, the small one, which looks like this, and the bigger one, which looks like that. Now for the page background image, it's still showing the old image, although we don't need it anymore in our project. But what we want to do is to show some graph background image. And for that I've created this image in the tool called Photopea, which is a free online graphic editor similar to Photoshop. And the image is in the same size as the display, being 800 by 480 pixels. And I've also created those green overlays with a few predefined multipliers, hoping that it will help me guess the right multiplier later on. By the way, you can see that for the graph I have a quite limited range of RPM values going over to 4500, and that's because I'm testing this with my old diesel minivan, and that's also why the kilometers per hour only goes up to 110, because my car is quite slow. So let's export this as the PNG image by going to File, Save as PNG image, click the Save button. That will export the image and then jump back into the Nextion editor. And in here I will add that image by clicking this plus icon and select that PNG image. And just because the page background is still showing the old image, I will change the pic to some random number, for example 1, and then change it back to the ID 0, and that should update the image. Now what I want to do as I'm driving, I want to draw some tick marks or maybe some circles on this graph. And there should be a function for that. If I go to Help and open the instruction set, there should be a function for drawing the circle, which is called the cir, like circle. And we should provide the X and Y position, the radius and the color. So let's just copy this example down here. And I will test it inside the Nextion editor by adding a new button. And let's change the font to be the smaller one, which is ID 1, and change the label to test. And I will paste the circle function into the touch pressed event. And then try this by clicking the debug button. And if I press the button, it will draw me the circle, but I think that I want the filled circle instead. So let me go back into the instruction set, and the filled circle is this function. So let me just change it for this button to be this function instead and debug it one more time. And now when I press the button, I can see the filled red circle. Now one important thing when drawing circles and other elements using the code is it will draw it on top of everything, but as soon as some Nextion component will be redrawn, it will actually redraw our drawings. And we can easily test it if I place another button in the place where the circle was drawn, maybe around here. And if I debug this one more time and click the test button, it will draw the circle on top of everything, but as I press this button, it will override the circle. So that's something to keep in mind, but we can use this to our advantage to basically clear the screen. And let me just change the font to be font number 1 and change the label to be clear. And we can very easily clear the screen by just setting the background image to be the one that's currently being set, so setting the pick to 0. So for the page, which is page 0, so page 0.pick equals 0, and it should clear the screen. So let me just test it one more time, and if I click the test button, it will draw the circle, and if I click the clear button, it will set the page background image, which will clear all our drawings. Now I probably want this circle to be in the smaller size, for example only 3 pixels instead of 30, and maybe the color could be green instead of red. So let me test it one more time, and I think that this looks much better. So let me just make those buttons slightly smaller. And let's test it one more time to see if everything still works. So click the debug button, and if I press the test button, it will draw the small circle, and if I click the clear button, it will clear the screen. So I think it's time to upload this project to the Nextion display. And for that, I will first connect the Nextion display to the USB to TTL board. This one is directly from Nextion, which has the advantage of just using one cable without needing to care about the connection. And then I will connect this USB to TTL board to my PC using this strange USB cable, which has the same connection on both ends. It's the USB-A to USB-A cable. And then jump back into the Nextion editor. And in here I will click the upload button, and you can keep all the settings to default, but if you want to upload it faster, you can open the COM port, and the one that we are looking for is most likely the last one, this one, and I will click the go button. And after a few seconds, in this case 18 seconds, the project is uploaded to the Nextion display. And in here I can press the same buttons, so clicking the test button will draw a small circle, and clicking the clear button will clear the screen. Which means that we can move on to the next step, and that is drawing those circles using the Arduino code. And I have this 3D printed holder from the last time that has few components. It has the SparkFun OBD2 to UART board. That one is being connected to the OBD2 simulator, and later on it will be connected to my car. To the SparkFun board is also connected the Arduino Leonardo, and to the Arduino Leonardo should be connected the Nextion display. So let me just reconnect the Nextion display to the Arduino Leonardo, and then connect the Arduino Leonardo to my PC using the USB cable. And the Nextion display is getting the power from the Arduino board, so we should still see the same graph background image. By the way, if this setup is confusing to you, please watch my previous video where I describe every single step and how to connect everything together. As a next step, I will open the Arduino source code from my previous project, and if I open the source files from the GitHub, it's this INO file inside the Arduino Nextion dashboard. So I will open this INO file in the Arduino IDE. So here it is, and there are some comments, and then there is the setup function going on, and then inside the main loop I'm getting the RPM from the OBD2 board and updating the Nextion screen, which is this section of the code. So I'm updating the Nextion readout and the Nextion gauge, and I don't need any of that, so I'll just comment it out, as well as the delay. And I will do the very same thing also for the vehicle speed, so I'm getting the speed from the OBD2 port, and then again updating the readout and the gauge on the Nextion display, and I will just comment it out. Because instead of that I want to draw a circle on the Nextion display, and for that I need two new variables, and let's call this Nextion.x position and the Nextion.y position. And for that we will use the speed value, and let me just scroll up, and we will also use the RPM value. So the x position is based on the speed value, and let me also open the photop file, because I want to remap the speed which goes between 0 and 110 km per hour, so going from 0 to 110, and I want to remap it to the pixel value starting from the value of 100, because that's where the graph starts, so 100, going all the way to that line, and if I select the selection, that's the x position of 760, so 760. But because there is a possibility that the speed could go over 110, I will also constrain this, so constrain this to only go between 100 and 760. In the very similar way, I will calculate the y position based on the RPM value, and again I will remap the value, so the RPM goes between 0 and 4000, so 0 and 4000, and the starting point will be in here, so y being 50, going all the way to that position, which is the y value of 450. And again I will constrain this value to only go between 50 and 450, And there is one important thing. I'm remapping this value to go between 0 and 4000, but I want to remap it from the other way around, so going from 4000 down to 0, because on the Nextion display this is the 0, 0 position, the origin, but I want to start on the bottom and increase the values going up. So we have the x and y values, and we want to draw the circle on the Nextion display. And let me just quickly open the Nextion editor and copy this piece of code, because this is what we want to send to the Nextion display from the Arduino code. So this is what we will be sending, and I will use this Nextion software serial to print this to the display, starting with this CIRS command with the space. The next parameter is the x position, so again I will use the very same print command, but this time I will print the Nextion.x position. Then I need to print one more comma, and then print the y position. And then I will print the comma and the size of the dot, which will be 3 pixels, the diameter, and the color, which will be green. Finally, in order for this to be recognized as the Nextion command, we need to send 255 characters. Just like that, and I believe that's all that we need for our Arduino code. So select the correct board, is the Arduino Leonardo, and then hit the upload button. And once the Arduino code is uploaded and everything is connected together, again the OBD2 simulator, into the SparkFun OBD2 UART board, into the Arduino Leonardo, into the Nextion display, I should see a green dot on some position, and that's this one. And as I'm changing the RPM value on the OBD2 simulator, I'm moving the dot up and down. And as I'm changing the speed, I'm moving the dot left and right. And of course, I can turn both potentiometers at the same time, because that's what will be happening inside the real car. So I think it's time to test this inside the real car and hopefully plot some nice looking graphs. And you can see that after driving around for a while, some data emerges. All those points around the 800 RPM, this is the engine idling, this is the neutral, and then there are those lines for individual gears. And I have to say it was really helpful to have this live instant feedback, because initially I was thinking about capturing this data and then maybe importing those into Excel, but seeing those dots appearing live as I was driving allowed me to adjust my driving in a way to fill those empty spots. So if I take a closer look, you can see that, for example, the second gear might be the multiplier of maybe 70 or so, and maybe the third gear is around 50, but I don't actually care that much about the actual number for those individual gears. What I care about more is the threshold between those individual gears. So for example, this multiplier of 60 is a nice example because it's in between second gear and the third gear, and that's the number that I care about. So what I have done is I have overlaid the photograph of the Nextion display over my graph, and then I have eyeballed the multipliers for those individual gears to somehow match those dots. And here is the version also showing the neutral and the individual gear numbers. And then I have included the in-between multipliers in between those individual gears, which I will use in my code. And again, those are the numbers that I care about, so I will say that if the multiplier is bigger than 97, it will be the first gear. If it's smaller than 97 but bigger than 59, it will be second gear, and so on, all the way down to the multiplier of 22. So if the multiplier is smaller than 22, it will be sixth gear. But before I change the Arduino code, I will export this image one more time as a PNG image, and then replace that image in the Nextion project by selecting the image and then clicking this replace button and selecting this new image for the page background. And you can see that the background image hasn't updated, so we have to force it again by selecting a random image, which is any number, and then going back to 0. And I will add one more thing, and that is to show the current gear, and for that I will add a new number component and make it about this size. It's already using the big font, so I'll just change the background color to be black and the foreground color to be green. And I need to remember the component name, which is N0, because later on in the Arduino code I want to change it to show the current gear, and I will do it by saying N0.value equals some value, for example 4 for the fourth gear, or maybe 0 for neutral, and so on and so on. So with this little change, let's upload it to the Nextion display one more time. And for that I will of course click the upload button, select the port which will be the last one, and then click the go button. And again, after 18 seconds, it's being uploaded to the Nextion display. And everything should still work, meaning clicking the test button and the clear button, but now we have a slightly different background and a big gear indicator readout. So let's disconnect the Nextion display from the USB to TTL board and connect it back to the Arduino Leonardo board. And let's jump back into the Arduino IDE. In here, I want to calculate the gear, so let me just scroll down all the way to the end of the sketch. And after we draw the dot on the Nextion display, we want to calculate the gear, and for that I will create a new variable and call it current gear. And I will create one more variable and call it gear divider. And I will calculate the gear divider as the RPM value divided by the speed value. But before we use that gear divider value, I will add the if statement saying that if the RPM value is below some threshold, and that threshold is around 800 RPM, but just to give it some space, let's maybe go with 850. And I will also say or if the speed value is below some threshold. So if the speed value is very close to 0, for example, smaller than 1 or equal 1, in that case the current gear will be neutral, so the current gear equals 0. And if that's not the case, we will use those individual multipliers or dividers to get the current gear. So let's say that if the gear divider is bigger than 97, in that case the current gear will be the gear number 1. If the gear divider is bigger than 59, it will be the second gear, and so on and so on. Finally, if the gear divider is smaller than 22, the current gear should be gear number 6. And so once we have the current gear calculated, I want to again send this value to the Nextion display. And again, the component name in the Nextion editor is N0, so we want to change the N0.value. So let's just send a string to the Nextion display saying that N0.value equal some value. And that value is of course the current gear value, so I'll send the current gear value. And to recognize this as a new comment for the Nextion display, I need to again send 255 characters 3 times. And I've noticed a small mistake. I don't want to send the current gear as the string, I want to send this as a value, so it shouldn't be inside quotes. And I think that the only thing left to do at this point is to upload this to the Arduino Leonardo board, so just make sure that the Arduino Leonardo board is being selected and then click the upload button. And I can again test this using my OBD2 simulator. By rotating those two potentiometers for the speed and the RPM values, I'm changing the position of the green dot on the graph. So for example, right now I'm around the position of the gear number 2, and the gear number 2 is being correctly displayed on the left side of the screen. And if I increase the speed and go over this threshold, this dotted line, it's now reporting a third gear. In a similar way, if I lower the RPM and go below this 850 RPM threshold, now the reported gear is a 0, which means neutral. So everything seems to be working fine using this OBD2 simulator, so let's try it also inside the real car. And you can see that as I'm driving, the graph is updating and the current gear is being reported. And it works mostly fine. I say mostly because it's not perfect, there is definitely space for improvement, but I want to save something for the next video because right now I want to talk about the Nextion display. And I've mentioned that multiple times in my older videos, those displays are great for prototyping because they are very easy to use, but not so great when you put them outside because they don't have very high brightness and the contrast is also not so great. So I want to replace this Nextion display with a different display, and that's this one. This is the square display from the company called DWIN. I've actually used the DWIN display for one of my older projects, being those Ford Focus RS gauges. I will put the link down in the description and you should definitely watch it if you haven't seen it already. Today's display is actually in the square size and you can see that all the components are on this flexible PCB. There is also this double-sided tape around the edge of the display, so it should be very easy to incorporate this into your existing project. The good news is that same as the Nextion displays, the DWIN displays also use the serial communication to set values on the display, but they use different connectors, and in this case it's this FFC cable, the flat flexible cable connection. And the easiest way how to work with this connector is to get the dedicated board right from DWIN, which is this one. It also works as the USB to TTL board. There is also this micro SD card holder which you can use to upload your sketch to the display, and there is also a buzzer because that one is not being included on this flexible PCB. So let me connect this board to the display and also to my PC using again this USB-A to USB-A cable. And then of course I need some graphics, some images to show on the display. And I'm trying to replicate this look from the Hoonicorn Mustang video. And after a quick Google search, I have found this logo, so I'll just download it. And this is the downloaded vector file that I will open in Photopea, and it looks like this. But since my DWIN display has the resolution of 480 by 480 pixels, I will create a new document in that size, so new document 480 by 480 pixels. And hit the create button, and then I will just open those layers, and this one seems to be empty. This is the line and this is the rest of the skull, so I'll just select both of those and merge those into one layer, and then move this layer into my new document. In here I want the background to be black, so select edit, fill with the black color, and the logo should be light gray, so just double click the layer and select some light gray color, maybe slightly tinted to the blue color, maybe something like that. And then I will resize it by going to Edit, Transform, Scale, and scale it down to only take about half of the display size, maybe something like that. Now this looks nice, but I want the inside to be filled, not the outline, and there are many ways how to do that. I will just duplicate this layer in case I will need the original one later on. And since this is the vector layer, it's made from vector shapes. And I think that what I can do is I can select the direct selection tool, which is this one, and then select those individual points on the outside and simply delete that shape. So let me just hit the delete button to delete this point and that point and that point. And at some point you will notice that, this is getting inverse selections. So as I'm deleting the outside, the inside is getting filled instead. So let me just continue like that with all the arrow points. Like so, and now we have the inside being filled, but it looks like that this one line inside the skull is missing. If I select the path selection tool and select that layer, I can select that shape and make sure to set the path to be subtract instead of unite, and that should fix it. So now we have the logo. Let's also add the gear indicator label. So select the type tool and just type in something, for example digit number 3, and I will change the color to be white. And I believe I was using this font, which is the Barlow condensed in the semi-bold style. But I will make it much bigger. Actually, I will type in some bigger value, I don't know, maybe 350 or maybe even 400 points. Actually, let's go all the way to 450 points just to take most of the screen space. Now in the original design, this font was stencil, meaning it was split into different shapes, and we can easily simulate it by selecting the line tool. I will set the fill to be black color and no outline, and the width of the line to maybe 5 pixels, and then I will draw the line like that to split the shape into multiple shapes, and for the top part I can either draw a shape like this, or I can for example draw it in an angle, like maybe matching this line, to have a stencil like that, but I think that in this case I will go with this shape. So once we have the design, I will save it as a JPEG file by going to File, Export as JPEG file, and that's because the DWIN display requires JPEG images. I will increase the quality all the way to 100%, and one important thing is that we need to start the name with the number starting from 0, so I start with 0 and then say DWIN Gear Background, and save it as a JPEG file. And then I will start the DWIN DGAS application and create a new project. And in here set the resolution to be 480 by 480 pixels and select some destination and click the OK button. And we want to add a new page by adding our image by clicking this plus icon and selecting our JPEG image. Now it's worth noting that this image is just for the preview inside the software, and to upload this image to the display itself, we need to convert that into the ICL file. And we do that by going to Settings and opening this DGAS serial port utility. And in here I will click the ICL tool to convert the images into the ICL file format and click the Select Pictures, and I will open my background JPEG image. And since this is already a JPEG image, I will click this Skip Original JPEG Images checkbox and then click the Generate ICL file. And the ICL file with background images should start with the number 32. So let's call it 32 and then maybe background images. It doesn't matter what's the rest of the name. And save it as an ICL file, and then back inside the DWIN application I will save that file. I will click the generate and export. I don't think that all of those are necessary, but just in case. And then I will upload this to the display by selecting the same utility again, which is this one, the DGAS serial port. And I have my USB to TTL board connected to both the display and my PC. So I will just click the refresh serial port and select probably the last one, which is this COM15. Then click the select files button, and I want to update all 4 files, which is the touch bin file, show file, configuration, and the background image. So select all of those files and then click the start downloading button. unfortunately, once this is uploaded, I don't see any difference on the display. I mean, I cannot click on anything, but it's still showing the old background image. And since there were no errors displayed during the upload process, I think what's happening is that this display is configured to use a different number for the background image. And that's because in this utility, you can create a new configuration file and change the address for the background image, which is this one, but I don't know if there is a way how to get that information from the display. But what I will do instead is to not rely on the background image, but to add one more image, which is this one, variable icon display, and just drag it and draw it like that. And as for the icon file, I will select our 32 background image for that image, and as I move it around, it will update itself. Actually, probably not. I need to just click this one and select that image, and now it should update. Since I have only one image, I can keep all those values to 0, but I need to set some unique VP address, for example 1000, and unique SP address, for example, I don't know, 6000, it doesn't matter that much. And then I can again save this project and then export this, actually generate and export, and try to upload it one more time by going into the gas serial port, and then click the select files. And since I haven't changed the background image, I will only select those 3 files, and download, actually upload this to the display. And we can finally see our image, although it's being transparent, still showing the old background because I did forget to change that settings, but that should be a simple thing to fix. For our variable icon, I will change the display mode to be show background, generate and export, and upload those 3 files to the display. And we can finally see our background image on the display without anything else that shouldn't be there. But a single image is obviously not enough for a gear indicator. We need a different image for every single gear. So we need to go back into Photopea and create those individual images. And to make things easier for exporting and aligning, I will say that the gear image will always be on the right side of the screen, on the right half of the screen, like so. And for that, I will create a new layer. So I'll create a new layer and then select the selection tool and set the size to be half of the screen, which is 240 by 480 pixels. Then select the selection on the right side of the screen and select Edit Fill with the black color. So this is the 240 by 480 pixel background. And I will select that layer, the number 3 and those dividers, and put everything inside the group by pressing Ctrl G and rename this group. And I want to start with -E- because that will make it easier for exporting later on. And then I want to use some numbers starting from 0, but I don't know what's the number because obviously gear number 3 shouldn't be the first one. So I'll just duplicate this one more time. And for that one, I will start with R for reverse. And then move those dividers around, maybe like so. And this will be the first image, so the image with number 0, and that will be the gear reverse. And then I will duplicate this layer, and the next one will be neutral, so N. Move those dividers around, like so. And rename the group to 01, gear neutral. And continue like this with all the other gear numbers. In the end, I ended up creating 16 different groups, starting with the R for the reverse, then the neutral, and then the digits for those individual gears going from 1 all the way to 9. Then just in case, I also have the park and the drive and the empty rectangle, and also the logo in the normal state and in the outline state. I probably don't need all those layers, but it shouldn't hurt because there should be enough memory on the display. So let's export those individual groups, and again, since I've used the -E- in the beginning of the layer name, I can go to File, Export Layers, and if I click this checkbox, it will only export me layers which starts with -E-. I will just change the format to be JPEG file in the biggest possible quality, and then click the Export Layers button. This is the content of the exported zip file, and again, I want to convert those images into the ICL file to be usable on the DWIN display. And for that, I will again open the utility, which is this one, and click the ICL tool, then select all my pictures, so those 16 images. And again, since those are already JPEG images, I will click the skip original JPEG file, so it will not do any conversion. And then I need to save it as the ICL file inside the DWIN set folder, and this time I will use the prefix of 33 and call it gear images. So save that ICL file and then go back into the decast tool, and I will add a new variable icon, so this one variable icon display, but this time I will use our 33 gear images ICL file. And since I have more images now, I will select the first one to be the number 0 and the last one to be the image number 15. And for the maximum value, I will also go with 15. I want the image to be non-transparent, so set the display mode to be show background. And then if I move it around, it will update itself. So I'll move it to the right side of the screen like so. And then I have to set some unique value for the VP for the virtual pointer, for example 2000, and for the SP for the settings pointer, for example 7000. Now I want to test this on the display using the touch input. So for example, I have some kind of slider, and as I slide my finger around the display, I want to change different gears. And for that, I will add a new touch component, being this one, the drag adjustment, and drag it maybe like this. I will set the dragging mode to vertical, because I want to drag it up and down, and the VP, the virtual pointer, should be matching the virtual pointer of this component, which is 2000, so 2000 also for this slider. And then I want to go over all the images going from 0 all the way to 15, so the start value will be 0 and the end value will be 15. Now I can test this project in here by going into the Show tab and selecting Preview from the first page. And let's not worry about fonts because we are not using fonts in our design. The problem is that the transparency is not working as expected in this preview. So while I can drag my mouse and change the number on the right side, I also see the digit number 3 which shouldn't be there. So just close this one and upload it to the display. So save and then click the Generate button and then click the Export button and then go into the DGAS serial port utility. Then select Files, and I want to select all of those files because the 33 gear images wasn't uploaded to the display yet. Click the Open button and upload it to the display. And once this is uploaded, I should be able to drag my finger on the right side of the screen and show all the individual images. So this works as expected, and the only remaining thing is to not change the image using my finger, but rather send those values from the Arduino. But before I do that, let's try to change the image using the DGAS DWIN application, because right now the display is connected to my PC using the USB to TTL board, which means that I should be able to send serial commands from my PC into the display in the same way that I will be later on sending those commands from the Arduino into the display. So let's jump back into the DWIN DGAS application. And in the utility, I will click the SP Order tab to send commands to the display. Make sure the correct port is selected, and this should be the speed. And I want to write VP, the value pointer. And again, the value pointer for our image is 2000. So the VP address will be 2000. And if I set it to 0, like so, and click the Send button, Send Order, it should show me the R, which is the reverse, which is the first image. And then if I go with 1, it will show me the N for neutral, and 2 for first gear, and 3 for second gear, and so on and so on. So this is the message that we want to send from the Arduino, the 5AA5 that should always be there, that should be the header. Then we have the number of bytes that we are sending, 05 meaning 5 bytes. The 82 command is for setting the VP. And then we have the address, which in our case is 2000, and the actual value, in our case 0321, and so on and so on. The only thing to keep in mind is this is the hex value, so if we want to change the image to be image number 15, we have to send the value 0f, so it will be 0f for the last image. And knowing that, I think that we can jump back into the Arduino IDE and send those commands from the Arduino to the DWIN display. So this is the current sketch for the Arduino Leonardo, and I still have it connected to the OBD2 UART board as well as to the OBD2 simulator. So if I open the serial monitor, I should still see the RPM and the speed values, which are being sent from the OBD2 simulator. And I'm still updating the gear value on the Nextion display, but again, I want to update it on the DWIN display instead. And I will open this video with the 4th RS gauges, again using the DWIN display, and open the source files on the GitHub. And I'm looking for the INO file, which is placed inside this folder. And this sketch is actually very simple, but I'm looking for two things. The first one is the speed for the serial transmission, which is this one. And the second one is sending the value, which is this piece of code. So inside the Arduino code, I will first change the speed. And that's for the software serial, which is this one. And it's called Nextion software serial, which is obviously not true anymore. So let me just quickly replace it with some more meaningful name, being the DWIN software serial port. And I will replace all the occurrences of this. And then if I scroll all the way to the bottom of this sketch, in here we are drawing the dot on the Nextion display, which we don't need anymore. Then we calculate the current gear, and then we update the gear indicator on the Nextion display. Again, we don't need it, so I will just comment it out. And from the GitHub code, I will copy one of those blocks of code, for example this one, and paste it inside our sketch. And as I've already told you, we need to first send the 5AA5, which is the header of the message, then the number of bytes, which in our case is 5, then the set VP, which is the comment 82, and then the address, in our case it's 2000. And then we want to send 2 bytes for our value, which is the current gear, but for our current gear, 0 means neutral. And if I quickly take a look at our DWIN project, here the neutral is the image number 1. So inside the Arduino code, I will create one more variable and call it current gear image and set it to the current gear plus 1. And then I will send the value of the current gear image to the DWIN display like so. Now we want to send all that data into the DWIN software serial port. So let me just do that. And then select the Arduino Leonardo board and try to upload it. And there is some kind of problem with this line of code, and I think what's happening is as we are trying to send the byte value of 0, this function is not quite sure if we are sending the byte 0 or if it's a null character, which is the end of the string. So I think that what we can do is we can just cast it to byte value and try to upload it one more time. And this time it uploaded without any problems. So let's take a look at the DWIN display. Because even when we are sending data from the Arduino Leonardo board, we don't have it connected to the DWIN display yet. And since we are only sending data from the Arduino to the DWIN display and not receiving anything back, we only need to connect the TX, the transfer pin from the Arduino to the RX to the receive pin on the DWIN board. And there are multiple serial ports on the DWIN display. I believe that we should be using the RX2. So the TX from the Arduino, which we have defined to be the pin number 11, should be connected to the RX2 on this DWIN board. And as soon as I do so, the image will update to show the current gear. And of course, I can still change the RPM and the speed values on the OBD2 simulator to change the current gear. Now before I end this video, I want to talk about a few things. This SparkFun OBD2 UART board seems to be out of stock, at least on the official SparkFun website, so the next time I will try to use those cheap ELM327 adapters from the AliExpress. The actual gear calculation could be a little bit better. Sometimes it will briefly show a wrong value, and that's usually when you press the clutch pedal and when you want to change gears. And that's because if you press the clutch pedal, the RPM will go down but the speed will not change, so sometimes it will think that the higher gear is engaged. So that's something for the next time. If you have any questions or comments, please let me know in the comment section. As usual, all the source files are on GitHub, the link is in the description. Thank you very much for watching, and I hope to see you soon. Thanks and bye.